Good morning, everyone. Thanks for joining us today for the Google I/O Extended 2021 with GDG Cloud KL. I am Amrita. I'm the lead for GDG Cloud KL. So for those of you who are joining us for the first time, let me briefly introduce you who we are. So GDG Cloud KL is a friendly non-profit community of developers working with or interested in learning more about the Google Cloud Platform. We host events to create opportunities for amazing developers with similar interests to meet and share ideas related to technology. So today, for Google I/O Extended 2021, we will be introducing you to some cool technologies and opportunities you can explore. We'll be having two sessions today. So the first session would be by Divya. It would be on Vertex AI, a unified managed machine learning platform on Google Cloud. And our second session would be by Hairizuan, and that would be an introduction to Google Cloud Run. So for those of you who have joined us already, do share with us a little about yourself, like where you're from or what was the highlight for you from the Google I/O this year. So without further ado, let me introduce our first speaker. So our first speaker is going to be Divya. Divya is an analytics development lead at Johnson & Johnson. So she develops and supports the development and execution of a comprehensive analytics platform, roadmap, and strategy with the core team, and architects the solution on major cloud platforms. She's the co-founder and head of curriculum at Big Data X, a community and technical workshop speaker, and a hands-on facilitator covering areas including big data and cloud computing since 2018. Divya is also a Google developer expert on GCP data and analytics, and the coolest thing is that she's Singapore's first woman GDE. So without further ado, let's bring in Divya. Hi, Divya.
Hi, Amrita.
So thanks a lot for joining us today. So before we get started, it'd be great if you could share with us a little about what you're going to talk on today.
Sure. So today's my talk is on Vertex AI, which is a recently released unified managed machine learning platform on Google Cloud during Google I/O event, which we had it way back in May. So it's a unified machine learning platform. So because challenges currently which we are facing, everybody wants to do machine learning. We had gone through a data analytics almost couple of years we are doing it. But now it's time to have a machine learning, and most of the people wants to do it. Most of the organization departments wants to do the machine learning. So that's where the Vertex AI comes into the play. Vertex AI helps you, like whether you're a novice or whether you are a data scientist, it's for everybody. And it helps you to have one platform to manage your models, to deploy your models, to develop your models. That's all about Vertex AI. I'll talk about more about when I gonna share my slides during the presentations.
All right, sure. That sounds great. So I'll probably share Divya's screen. Divya, could you please share your screen and we can get started now? Yeah.
Sure. So let me share my screen. Let me know if you're able to see my screen.
Yep, it's all good now. Yeah.
Okay, thanks. So yeah, a little bit about me, though Amrita has already shared intro about me. So myself, Divya, I'm an analytics development lead at Johnson & Johnson Singapore, and also a Google developer expert for Google Cloud, and a co-founder for Big Data X. It's a prominent tech community in Singapore, which does the hands-on workshops on Google Cloud, on the cloud and big data. If you want to connect with me, here's my LinkedIn, and you can follow me on Twitter as well. So when we talk about the ML modeling and all, so that's the challenge currently which we face it, right? So we have the solutions already built But how do we, manually? We have already developed the model. Maybe it's in multiple machines, or maybe we already procured a hardware for it. But now, how do we manually, you have to go through that pipeline, ingestion of the data. You have to train your model, then you have to develop your model, and then you have to deploy your model. But all this currently, you have to go through a different phases. You don't have a pipeline set up at this point of time. I don't see it any solution which is currently be there in the market. So that's where the Vertex AI, it comes into play. So Vertex AI is a unified managed machine learning platform on Google Cloud, and that's the title of my presentation as well for today. So agenda which I want to walk you through is like what the challenges which usually we face if I deploying the ML model to the production. What is Vertex AI? What does the Vertex AI fit in? What's included in Vertex AI? And how does Vertex AI helps with ML ops? And there's a demo like how to train and deploy the custom model on Vertex AI. How do you do it? But they say like the picture says 1,000 words. It's similar to 1,000 words. So this is what all about. Like, so when somebody who is already working in ML ops, right? So they know like it takes a more time. If you already develop your model, it takes deployment. Even if you need to productionize it, you have to go through a many cycles of it to procure the hardware, whether you need a TPU or GPU. You need to test around. There's a testing environment which you need to set up and all those. So that's the challenge usually we face it in AI world. So I talk about now, I'm going to talk about the challenges currently we are facing. So if we already have a model in place, and if I get like so much of traction and I need to scale up my model, so I have the limited hardware to scale up. So then I need to go and then check it like whether I need more TPU or GPU. So that's a scaling up is harder. The versioning and reproducibility also a challenge for us. Testing of a model. So I'm testing a model with one data set, and then I need to test it with another data sets. That's where the challenge is validations. Again, the testing. So if I'm deploying a model with one version, and then I need to deploy to another version, I need to do the A/B testing. There's a challenge because I need to test it with the same data set. And then model monitoring also, that's another challenge which we usually face it. Like, how do I model it? Like, is there any anomaly detection? Is there anything else which I could see? Is my model is behaving properly in production or not? All those challenges which you currently face it. Now, what is Vertex AI? So Vertex AI is a managed ML platform for practitioners to accelerate experiments and deploy their AI models. So where does Vertex AI fit in? So Vertex AI is nothing but it's a back-end ML platform for your development and deployment. And then that's where your application logic sits in at the front. And then you will be able to serve your clients, whether it's a mobile client or a desktop client. So it's a complete solution for your ML needs. But what's included in Vertex AI? So whenever we do the ML modeling, we go through all these cycles of ingestion, analysis, transforming of the data, training, tracking, and then evaluating. So in ingestion, what's included in your website? So you have the ingestion. So you can currently Vertex AI supports ingestion of your data. Like, so you can have one single source of truth of your data source, whether you can store your data in Google Cloud Storage, or you can store your data in BigQuery as well. So that's what you do it. You can label your task. You can do the analysis there through the BigQuery, or you can have your own custom program. Then you can transform your model. You can train it either through AutoML, or if you have your own custom code, that also you can do it. And then you can track your models, like you can compare your models as well. You can evaluate your models as well, and then you can deploy it for the production. So this is the Vertex AI pipeline usually which we go through. So you gather the data, you train your model, then you scale. You think it like, okay, whether you can scalably deploy your models, and then you can streamline workflows with the pipelines. And you can evaluate, model, retrain, and then if it doesn't fit in, like you can gather some more. So that's how the whole pipeline works. Vertex AI supports both UI based and the code based model. So if you have, like, in the organization you want to try ML modeling, you don't have to, like, so you don't have to worry about, okay, now have got it, I want to try the prediction analysis, but I don't have that skill set. So you don't have to worry about it. Vertex AI provides you step by step steps through the UI. Or if you have some skilled data engineers or data scientists in your organization, then you can go through the code-based model development. So it's for both. It's for novice to expert data scientist. So now, how does Vertex AI helps with ML ops? So if you see it, all the oranges which are highlighted, these are the current feature which is supported by the ML ops. Feature store is like, so usually that's the challenge which we usually face in the ML world, right? So you already have the featuring of that one data set, and then you want to use it for different use cases. So every time when you do it, every time you need to do the featuring. So but in Vertex AI, you can reuse and you can share your feature with other other team, and then you can serve your ML feature at the scale, and you can alleviate the training, the serving skew. So you can do it in the, so it's all available at one platform. Then you can do the continuous monitoring. You can do the continuous monitoring. You can set the automatic alert for the data scientists, for the ML engineers. But at times when the model goes into the production, right, you could see that you're not sure whether how your model is behaving, or you have to manually monitoring it. So instead of manually monitoring it, you can set an alert in the Vertex AI, and whenever there's a performance changes of the model, you can get that alert. You can do the provide confidence in the model reliability. So if there are any changes, you can set the threshold also. Okay, if my model performance goes beyond that, send me the alert. So it will detect the drift and training skewing also. Metadata, so it helps you to manage the metadata also. Like the Vertex AI supports 4 data sets at this point of time. It supports video, it supports tabular data, it supports images data. So 4 data sets, it supports it at this point of time. So if you have any of these data sets, it has the UI to do it. But it also have the custom. If you have anything which is like, okay, you have already is the model, you have already deployed on any container, you can bring back in your Vertex AI, and then you can deploy it, and then you can scale it up anytime. So you can define, you can deploy it, and then you can scale it as per your need. So that's the all about Vertex AI. So it's a demo time. I'll just walk you through the demo.
First
like how do you deploy the models in Vertex?
For this step, my friend Sarah and I collected a bunch of images from our yoga practice and uploaded them into the managed datasets. As you see here, the images are labeled in 5 categories. I can even upload unlabeled images and label them. We can analyze our dataset to see that we have enough examples of each categories. Now we are ready to train our model. In here, I'm selecting AutoML for training method. You can also train a model to deploy on the edge or on premise, or use custom training if you're writing your own custom model code. Now we define our model. AutoML automatically splits the data into training, validation, and test, but we can change it if we want to. In compute and pricing, we get to select how many node hours we want to train the model. At this point, we wait for the model to train. Once it is trained, we see it in the Model tab and can evaluate the model. We can see our model's average precision. It ranges from 0 to 1, where a higher value indicates a higher quality model. We can see that the confusion matrix helps us understand where our model is confusing 2 results. Now that we have evaluated our model, it's time to deploy it to an endpoint. We can split traffic between 2 models deployed on the same endpoint if needed. Allocate the number of nodes needed for this endpoint. Depending on where your users are, select the region to deploy your endpoint. And that's it. Hit deploy, and we have an endpoint. Now we can test our endpoint and the model by uploading an image. And yay, it works! You can also make predictions using the SDK. If this has piqued your interest in Vertex AI and you want to learn more, head over to the documentation linked on screen. Thanks for watching.
Yeah. So you have seen how easy it is to deploy a, ML model in Vertex AI. So this is the, like, if you are in no voice and then you want to do the testing, like this is how you can do it. You can go to the Vertex AI console in Google Cloud and you can test your models. It has the feature of deploying the custom model as well.
Hi everyone.
If you want to learn more, you can watch some more videos, how to train and deploy model on Vertex AI, how to build end-to-end solutions using Vertex AIs, and there's a Vertex AI series as well. And if you want to do a really hands-on, there's a collabs on Vertex AIs, how to build a fraud detection model with AutoML and the Vertex AI training and serving a custom model. Yeah, so if you want, you can follow us on the Meetup, LinkedIn, and Facebook. On Big Data X if you want to follow it. Yeah, so that's about my presentation. Over to you.
Thanks, Divya. It was great. Yeah, I think it was incredibly amazing how Vertex AI can help people from different groups, like different experiences and stuff. So I'm pretty sure that many of our audience have had a great time listening to what you shared on Vertex AI, and I'm pretty sure that they would love to try it out themselves. So yeah, so Divya mentioned that she would be sharing with us the slides as well. So for those of you who would like to try it out, do join us. I mean, we would share it on our platforms after the event, so stay tuned for that. Before that, we have a question. So yeah, here's the question from Sabo. Sorry if I didn't pronounce it right. So yeah, they're asking if Vertex AI allows to auto retrain model. So Divya, would you like to take that question?
Yes, so Vertex AI helps you to it has a capability to retrain. So it has a feature in the Vertex AI where you can retrain your model. So you can, once you go through that Vertex AI UI, which is there in the Google Cloud, you will get that. And again, I just wanted to add on top of it, you can, if you have multiple models also, right, you can compare your models also. So it has that feature as well. You can compare our ML models if you have multiple models, developed by your, for different business use cases, or or developed by different team members. So that comparison also you can do it.
Thanks for answering that, Divya. I hope that has answered your question as well. Right. So yeah, let's move on with our next talk. Before that, would like to let you guys know that Divya would be staying on as well. If you have any questions, you can also direct it to Divya and she would answer it towards the end of this event. So thanks, Divya. Now let's introduce our next speaker. I think it's still loading. Okay. Yeah. So our next speaker would be would be giving an introduction to Google Cloud Run. So we'll be introducing our speaker, which is Hairizuan Noorazman. He is a DevOps engineer at Acronis. Hairizuan is an avid fan of tools and technologies and has dabbled in various programming languages such as Golang, Python, and R. He's currently one of the co-organizers for the GDG Cloud Singapore meetup group. So anyone from GDG Cloud Singapore, yeah, shout out to our co-organizer here. And let's bring Hairizuan. All right. Hi, Hairizuan.
Hello, Amrita.
Yeah, so
Good to be
joining
here.
us. We're thrilled to have you here as well. So before we get started, could you please explain to our audience here what is this talk going to be? A brief introduction.
Okay, so as the talk as the talk stated, essentially this talk is kind of an introductory session to Cloud Run. This Cloud Run product has been around in the Google Cloud Platform portfolio for quite a while. One of the more interesting tools that is available in the arsenal. I think I will explain more within the talk about why is more interesting or why is it more useful. Yeah.
Sure thing. Thanks a lot, Hairizuan. So I'll put up your slide and let's get started.
All right. Okay, so let's get started. So as mentioned earlier, the talk is on introduction to Cloud Run. Most of this talk is gonna be demo. Hopefully, the demo goes well so that you can see like how the functionality of this Cloud Run tool works for you. So I'll be demoing from the UI perspective, but naturally there's also, of course, the CLI version of it. So in the case where if you are in a company where you want to do like some DevOps related activity around this, it is definitely possible. Actually, it's more recommended to do it that way to make sure that you have a more consistent deployment across multiple versions of your app. So let's move on. Okay, so what is Cloud Run tool? So first things first, maybe we can talk and explore about this Cloud Run tool as compared to the rest of the compute options on the Google Cloud Platform. So if you watch this YouTube video there, it actually explains all the various options that Google Cloud Platform provides. It should still be accurate up till today. This talk is like quite dated, like maybe 1 or 2 years back, but it should still be relevant today. So let's go from the bottom, which is Compute Engine. Compute Engine is like one of the oldest products that GCP provides, and essentially it's just a virtual machine. If you want a virtual machine, you go to Compute Engine and you just create an instance of it, and that is where you have the most control. Like you are given that virtual machine, you can do anything you want. You can deploy your apps, you can do your machine learning or whatever. You have full grain control over what you can do with it. On top of that, you have Kubernetes engine, which is essentially just Kubernetes as a service. I'll skip over Cloud Run as I'll explain the other two so that it makes more sense. So App Engine and Cloud Function essentially is you just write your code and without caring about runtime or how it's deployed, you will like ask via CLI to and ask Google to deploy that code for you. You're not caring about the runtime of it. Like let's say if you are writing Python code, you're using these like App Engine CLI tools, you can just tell App Engine to like, hey Google, deploy this Python app. You don't need to care about how it's deployed. Essentially, Google takes care of that for you. All you need to do, at least for App Engine's case, is have some sort of YAML file, describe your app in that YAML file, and then like Google just takes care of it for you in terms of how the application scales and whatever. Similar with Cloud Functions. So Cloud Functions is even more minimalistic as compared to App Engine. So in terms of as you can see on screen, in terms of degrees of control, so as you go up further up this slide of compute options here, you are given less and less control over your environment. So at the top, you only focus mostly on your code, runtime, be them, just leave it all to Google. So Cloud Run kind of sits in the middle of all this. Cloud Run essentially, to put it simply, it involves just having a container, a Docker container, or whatever, and you throw that container to Google and ask Google to run it. So it's a slight abstraction on top of Kubernetes engine, but not exactly like App Engine. So that's why it's kind of in the middle. So in terms of degrees of control, that's why it's kind of there. Yeah. So so as I was mentioning in the earlier slide, Google Cloud Run is essentially just taking containers and running it as like a function on Google Cloud. So there are definitely some benefits on top of this. So like before Google Cloud Run existed, Google Cloud Functions was there, but the main detriment for Google Cloud Functions is that Google Cloud Function is completely dependent on what languages that Google supports. So let's say if you have like some weird language like R or Haskell or Rust, yeah, those are not exactly supported. That's one. Another important thing of this like serverless paradigm is about the fact that you essentially run your code on demand. So let's say if you take the case of compute engine, when you create an instance of Google Cloud Compute Engine, you are actually charged on a per hour basis whether your app is running in the VM instance or not. So even if you create a VM and then you just leave it there without running any workload, you're still charged on the per hour basis. In the case of this Cloud Run or any of these like serverless products that Google Cloud provides, essentially you can configure it such that it will only start charging your card only when the function or when the code runs. So that's where it's really useful in terms of cost saving. It should be pretty high in terms when you're running like applications that doesn't have much workload. So rather than like me rambling along like what this cloud run is about and like uh how it functions and like the theoretical part of it, like it would be better to just jump into a demo and see how it will look like in terms of working with. So for those who are on the stream, who are following the stream, you can go to the website below there. Yeah, it's pretty long. Didn't have time to kind of like create some sort of like shortened link for it, but yeah. The slides will be available after this talk, so you can look out for that in case you want to try it out after that, after this talk. So okay, for this, like essentially this code essentially is just a hello world kind of code. Yeah, this code is just basically what I just showed in the slide just now. So essentially, it's just a simple API server exposed on port 8080. With it handles the API response on the index, like basically on the just a simple like slash path, and all it does is just returns just a simple message. So so what we usually do in terms of doing like handling containers and everything, you'll try to test whether it can build locally and can run locally. And once you tested that, then you can like get it running on Google Cloud Run. So that's kind of like how you can test it and deploy a app kind of safely for Google Cloud Run products. This is unlike Google Cloud App Engine. Google Cloud App Engine, you kind of require to rely on the G Cloud tooling. I believe there is some sort of like environment for you to test your code, but you kind of have to rely on it. And Google Cloud Functions, I'm not too sure whether G Cloud has anything. But yeah, I mean, those two products have to be dependent on a Google Cloud tooling and Google Cloud environment in order to test the code out. At least in this case, it's just a container, so you can rely on like your usual like Docker tooling. So to build this and to test it locally, let's just build this. I'll just name the image, label the image as lol, because like kind of easy to type there. Hold on, Docker build. Hold on, typo. Hold on, yeah. Let me see if there's something is missing. Oh, okay. I added an extra space there. So the dash T essentially is like what you want to label the image that's being produced here. So there shouldn't be a space between flags, right? So right now I'm building the image. Essentially, let me quickly show you the Docker file. I'm kind of using a cache image so that the build time won't be too long. So for this image, essentially is using a Golang 1.14 version. All it does is just add the files, build the app, expose port 8080, and then sets the command to run on application startup to /app. This is definitely a bad example. One would usually not use such massive containers in production environments, but this is just demo purposes. So now we have that image, which is lol. Let's try to run it. Run dash. I believe is port 8080. So we'll need to, when we are running the image, we'll need to kind of expose the image to our local machine. So that's using the -p flag. And then our image is lol. We don't need to pass a command to tell it on what command to run because we already have one within the image. So let's go with this. And then we should start seeing some sort of log when the application starts. Okay. Yep. And there you see as the log that says that application starts. And then we'll just need to go to localhost to make sure that, oh, sorry. This is kind of a cache. So we just need to go here, local 8080. So this is the message that's being written. And this is when we run in Google Cloud Run, this is what we should expect. Okay, so how do we get this image that we've tested locally? How do we get this image to Cloud Run? So step one is to actually get the image into Google Cloud Platform. Google Cloud does provide this tool called Container Registry. And Container Registry is what it says. It just stores images for you. That's kind of it. You can think of it like Docker Hub, but a private Docker Hub. In order to access it, you'll need to authorize your account, your local machine with local accounts to your respective project. So I have done that because like it's actually quite a hassle to do it. All you need to do is just follow the instructions in terms of accessing, pushing an image to container registry. If you search that on Google, you'll definitely immediately see the result on like the first 2 or 3 results. So let me stop this because we kind of prove that this is kind of working. Okay, it seems like can't like exit out, kind of hang there. Never mind. We can stop the image over here. Let's stop the image. Laughing kill B. We need to remove the image. Okay, so in order to kind of push this image to a container registry, you will need to build it once more, but we'll need to tag it in a certain way in order to tell Docker to push it to that container registry. So let me go and get the project ID. And this project ID is what we'll need in order to form that that URL. And let me clear this in order to make it clearer. In order to build and push that image, what we need to do is first you need to give gcr.io and then project ID, and then in our case, let's just call this image lol for simplicity's sake. Then put v1, version 1 of this app. And then after that, we need to put a dot to say this current directory. So let's build our image and sorry. Turns out that I am in the wrong folder. Okay, basic web. So right now I'm in the basic web folder, which is this current where this current file is. And let's run it again. And it should be pretty fast. Most of it is kind of cached. So now we have the image built with the correct tag. What we need to do then would be just to prove that I haven't exactly have this image on standby. I will show the container registry once more to show that we don't have the lol container within container registry. So yeah, as you see here, there's no lol. So it's a new image. So let's push that image here. It should be pretty fast because the image is not that big. I do have an experience with trying to push R images. R images are way larger. I think if I'm not wrong, one example of R image can easily hit 1 GB. So if you're not careful of what you put into the container, container sizes do get quite large. Yeah, so that's an important thing to just take note of. So we have pushed the image. Let's check that the image is here. Okay, you have the lol image, and there should be v1 there, so that's fine. Okay, so now we have this image in Google Cloud. What's the next step? Next step would be to deploy it. So let's go to Cloud Run. What I'm demoing here is via UI, so definitely there's a CLI version of it, as I was mentioning in the earlier part of this session. But yeah, let's do it via UI for now. So let's create a service. So in terms of service, let's just call it like something like test service or something. Region, we can stick with this. Okay, so this is the part that we select what container we want to run. So this is the reason why we need to kind of push it to this environment. For some odd reason, it doesn't really accept from Docker Hub anymore. In the past, it used to. It accepts from container registry or artifact registry. So what we want to deploy would be an image from our lol image, which is the version 1. As you can see, it's pushed 1 minute ago. We'll take this image, we'll select, and then that's it. Remember, it's going to be deployed on port 8080. So that's one thing to take note of. Here are some additional settings that you want to consider to change if needed. So there is like container port, what port to run it against, what commands, what arguments, etc. I think right now there's additional features coming in terms of whether to have whether to change on how the container would run. Yeah, it's mostly for the like job-based kind of workload. But yeah, you can read up more on this. I haven't like kept up with the Google Run release notes because like it kept coming over and over. So yeah, I'm just showing the simple demo case right here. In terms of capacity, so capacity essentially is like what it says is like in terms of resources that you want to give to this Cloud Run instance. So there now you can kind of run these containers with large amount of resources provided to it. So right now, easily up to 8 GB. That I think that's in general availability, but I think bigger container sizes will be coming soon. Like you can see, can go all the way up to 16, maybe more. Who knows? You can allocate more CPUs if needed. Request timeout is essentially is as it is. Like essentially, let's say if your request takes more than, in this case, 5 minutes, essentially the connection will be cut. So this is kind of the time like as it says, request timeout. And maximum request per container is how many requests can Google send to this particular container. And this mainly concerns with how much concurrency or how much parallel requests can your container hold or process at one time. So in certain, in Golang language is fine. Golang server can take on like a larger number of requests by default. Let's say if you use your if you build a normal Golang application, you can easily do that. But in certain languages, like let's say Python or R, these languages are usually single-threaded. And let's say if you have a long-running request, if you send 2 requests at the same time, the first request will go through. Second request will essentially be stuck. Like it's attempting to get the container to process it, but it's unable to because the container is like working on something else. So yeah, it depends on the language, on the tool, on what you're using. Other things that you might want to take note of is like auto scaling. Like this is primarily more to like cost control. If you don't have this mechanism, essentially Google can essentially scale this to a high number of containers, and definitely that will impact cost, and that's not a good thing. Sometimes this auto scaling really is handy in terms of, let's say, if you have some kind of bad logic in your code such that it creates it kind of, okay, maybe I'll go into that story like later on the slide. Yeah. Let's see what other things we can check on. Maybe for environment variables and secrets, we'll explore later. Connections. So right now, if you have if you are using gRPC or something, you need to turn this on. So that because gRPC is essentially HTTP2, and so this, like now Google Cloud Run does support that. You can connect it to SQL, etc. Right now we are fine with using the default account in terms of security. So yeah. So with this, I've gone through all the options available. So we are fine with this. It's a small app, 512 megabytes. It's fine. 1 core is fine. We can handle 80 requests. It's fine. So next, this part is in terms of how the service will be triggered. But so by default, the service is triggered via plain old HTTP request. So this Cloud Run can actually be the code for the Cloud Run instance can be triggered by other things. So you can like have it be triggered based on the Cloud pops up message. So let's say if you have like a big service and that sends like message to pops up, then the when pops up receives a message, it can push this message to Cloud Run to process it further, etc. One example. So in our case, this simple demo case, let's just allow all traffic because like it make it easier for demo, and let's allow unauthenticated invocation. So I think by default it's supposed to be private, but yeah, unauthenticated essentially is like public access. Anybody can access once they have the link. So with that, we covered most of the options. Let's just create the Cloud Run, the test service. And then right now it's creating it, it's pulling the image, etc., etc. It will create a new endpoint. And yeah, it's now quite fast. So this is what it will look like once everything is set up, everything's running. If you remember earlier, what the app does is essentially just prints a message. What's the message? Let me see what the message was. It should be basically just say this is a test, hello world. So that's what we should expect. Let's copy this and then let's paste this here. We should see some simple message, and this is it. So it's actually, this is kind of the basics of how we can deploy a container from our local workstation to Cloud Run on Google Cloud Platform. So this is kind of the basic thing, like basic thing that we would expect from Cloud Run, like basically just running container for us. But in recent days, I mean, it's not recent, it's like quite a while back, but yeah, there are new features being introduced in Cloud Run. So let me go back to these slides. Okay, basically this is demo. Okay, so before I go to that new features, etc. So there is this interesting mention during one of the Google Cloud Next events about how your concurrency settings can potentially affect how much money you pay for it. So if you think about it, the bigger your container that Cloud Run will be running, the more it costs. You can check the pricing page for Cloud Run. You should be able to see that. The bigger the container or the more resources you provide to the container, the more expensive it is. And with but the thing is, you need more resources in order to be able to handle more concurrent requests. So there is some sort of trade-off, pricing trade-off over here. So you can have a bigger container. Bigger container will last a bit longer, and it will handle more concurrent requests. Or you can go the alternative of having a smaller containers, which is cheaper and handling less concurrent requests, but it will spawn more of these instances. So you will be able to take on the load. It's just that you go for bigger containers to handle more concurrent requests per container, or smaller containers with handling less requests per container. But in terms of workload wise, it should be able to handle it. Yeah, it is a kind of an interesting watch. So you can just refer to that YouTube video there. Yeah, so this is kind of the feature that I wanted to talk about before I got interrupted by the previous slide. So in terms of, let's say if you have a new version of your app and you kind of want to test it and let other people like maybe let product managers or something test it out before the application like really goes live. So there's this feature that allows you to set a particular like testing URL. So let me show how this works. Let me go back. Okay, let's say we have this app and we are fine with it, but maybe like we need to like do some sort of change to it. So let's say we add like v2 to the text now. So now our application is now v2. And we need to deploy this version to Cloud Run. So what we can do is we can build it. This is version 2. Save it for real. Okay. Okay, and then let's build it. We are building this v2, so we'll need to then push it. So it should be pretty quick. Let's wait a few more seconds. It's almost there. So now we have a v2 container. So we will be pushing this v2 container to container registry. And what we want to do here would be to deploy a version of this container, but not have it like publicly available. Like it will only be available via this specific special URL, and maybe you will share this URL with product managers, etc. To make sure then the product manager can actually look at it like and check that the feature is working as expected, etc., etc. So let's go back to cloud platform. So I guess I don't need to show the v2 in container registry. We can just assume it's there. What we'll do here would be we'll click on edit and deploy new version, which is what we are trying to do here. Then first thing we need to do is now we need to select our v2 container. This is the next container that we're trying to deploy. So that's that. Port 8080, most of them should be kind of accurate. And there shouldn't be too much changes in the options. We'll stick to the current one. So, but this is the important option that we need to take note of. So when you're trying to deploy a new version, by default, all the traffic will immediately goes to the new version, because you want kind of like rolling update. I guess that should be a good default behavior. But in our case, let's say if we are not sure of this change that we're making, like maybe we're scared that we might break everything with this new version. Maybe you want to test it to make sure that it's all working well. What I can do is uncheck this. So that means essentially this app will be deployed but will not be accessible. Will not be accessible yet. So it won't exactly run. So once we do that, let's click deploy. We'll just wait and let it like run. And as you can see here, if you see where my cursor is like circling around, you can see that the version 2, the one that we just tried to deploy, is at 0% traffic. That means it won't receive any traffic. And we see our version 1 is still 100%. What I can do here would be copy this link just to show that it's not like we don't have any traffic from the v2. So I'll open a new incognito. I will put the URL for this service. As you can see, there's no like v2 in this message. So let's go back to this. Let's close the incognito first. Let's close the incognito. So like like how do we create that revision URL, that special URL that for the product manager to access. So what we do is we can click on add revision URL. Let's do v2 version, v2 dash version. I think in order to create the new URL, we need at least minimally of 3 characters. Yeah, there's kind of a limitation. Yeah, but I guess it's a decent limitation of sorts. Yeah. So once to v2 dash version. So in order to access this version, we need this specific URL in order to access it. So let's save this. And now, as you can see, the traffic is still like going to, most of the traffic should still be going to the v1. Just at v2 we have a special URL, so that allows us to kind of test, check to make sure that everything's working before before it really goes live. And then you can see if you click on that revision tag, you can see v2. Yeah. So yeah, so this kind of shows that it's working. So okay, that's good. That's a good thing. Now if we pass this link to like the people who kind of want to check for this to make sure that it's working, now they can actually verify and to see that it's like working fine. So let's go back to these slides. So what I just showed was the revision URL on the specific version. So the next kind of interesting feature for Cloud that Cloud kind of provides is this thing called traffic splitting. So this mainly concerns about, let's say if you have this concern that you're not sure whether your new version of your app is able to take on the request workload. Like you're not sure whether it's able to handle like a large amount of workload. So you would prefer like maybe 80% of the traffic should go to the old one and maybe 20% goes to the new one. And then maybe you'll monitor the new version of the app to make sure that it's not crashing too heavily, etc. Or like error logs are within range. So like Cloud Run does support this feature. Let me demo it to you right now. So going back to what we have, so let's say we have our v2 and v1, and let's say we are now happy with our v2 version. So let's say if we now are going to be fine to have a 50-50 split between the v1 and v2. So what we can do is just click on manage traffic, and then over here we just change our traffic to 50-50. If we have more versions, we can even split it even further. Yeah. So in our case, let's do a 50-50 split to make it more obvious that there is 2 endpoints and you can show it pretty frequently. But naturally, if in production, you won't do this. Maybe in the initial change of traffic, what you'll do is maybe like a 90-10. Is really to make sure that if it's really to get the new version to kind of test the waters to make sure that all is fine. But yeah, 50-50, we'll save it and let it do its magic. So that should be pretty quick. So now, as you can see, traffic is 50-50. So what you can do here would be copy that URL, paste it here. And what we have first would be a v1. But if you keep refreshing, you'll see that you'll alternate between v1 v2. It's not like v1 v2 v1 v2. Essentially, it's just you can expect that 50% of the requests will go to v1 and 50% of the requests will go to v2. So there's 50% odds you'll either go v1 or v2. Yeah. So yeah, So that's with regards to traffic splitting. So let me look at the time, 11:30. Okay. I kind of want to talk about this secret like stuff, but I guess we don't really have too much time. I mean, I've this session is already like about an hour already, so like I will leave more some information in the README with regards to this. So essentially, what this part is about is in Cloud Run in the past okay, so how do I phrase it? Google Cloud Platform now has this new product called Secrets Manager. Okay, let me quickly show it. I won't demo this feature particularly because it takes a while, but yeah. Let me go to here. It's under security. So if you scroll down a bit, go here, then there's Secret Manager there. It's under security. So let me show you here. So there's this new product called Secret Manager, and what Secret Manager does is pretty obvious. It manages secrets for you. So you can think of it something like Vault, I suppose. Yeah, so you can like create secrets and like store the secrets here. And now there is an integration between Secret Manager and Cloud Run. But I think it's still in public preview, so it's not yet GA. So if your company is insisting on like you can only use GA products, so it's maybe not yet time to use it. But yeah, hopefully it will be generally available soon. So let me go back to the slides. So regarding this secrets manager, essentially, like let's say if you have a if some kind of like API key that you need kind of need to store here, what you can do is you can use secret manager, and then the secrets will be you can mount it as a file within your container, or as an environment variable that your container can consume. So you can do either way, and then you have that capability and have that access in that container, and then your container can then just use it. So yeah, that's kind of basically it. Yeah, so yeah, there won't be any demo for this, but I will put in more information in the README for this So for those who are kind of interested to try this out, the code for this specific to test out this specific feature is in this link here. Yeah, so you can read the README and see whether you can have it working by following the instructions within the README. So some other interesting things with Cloud Run that you can do. So I was mentioning like quite a while back about how you can use Cloud Run, and then if Cloud pops up, maybe you have like some asynchronous workload. You can deploy it within Cloud Run, and maybe it takes like maybe 5-10 minutes to run end to end. You can have, instead of like sending a HTTP request which may break anytime, it'll be better to just like send the message to PubSub, and then PubSub will trigger Cloud Run and have Cloud Run like run the code to completion. So there's one possible use case. So I think I demoed the gradual rollout of applications. That's with the revision URLs and the traffic splitting. If I'm not wrong, these features are not exactly new to the Google Cloud Platform. Like I believe, if I'm not wrong, App Engine, Google Cloud App Engine does support this. So Google Cloud Run, Google App Engine is able to do that whole like a specific revision URL and traffic splitting as well. So if you want, you can try that with App Engine. But yeah, Cloud Run does support this as well. And then with regards to VPC support, so if you think about it, when you do Google Compute Engine, most of the time, if you have an app within Google Compute Engine, you're gonna put your applications in some kind of like private cloud to make sure that there's no public access to it, to make sure it's more secure, etc., etc. And let's say now you need to have Cloud Run to access some of the data from the applications within that within the virtual private cloud. You'll need to do that via the serverless VPC access. So that will also take a while to demonstrate. Can't do it today. Maybe there'll be videos in the future on this. Some other ideas that you can think of when you are trying to run with Cloud Run is maybe you want to try to stuff a browser into a container. Maybe you can do front-end unit testing. You can easily, because now it's just a container. So you can essentially what you can do is just install like Chrome within the container. Then maybe you have PubSub to trigger unit testing on it. So, and the best part is most of the time your unit tests, you're not going to run your unit tests like consistently. You're going to run your unit tests maybe like once in a while. So most of the time, you wouldn't want this machine to be up and running most of the time. So this is ideal. Like Cloud Run, if there's no workload, if there's no request coming in, it will scale to 0. You're not charged for it. So this is kind of ideal. It's an ideal use case. Another way is like maybe inference ML tasks or training ML tasks. Like I'm not too sure, because like sometimes training an ML does take a while, and if you are going down this path of using like managed services like Cloud Run, I think maybe it might be better to actually look back to Divya talk regarding Vertex AI to see whether that would be ideal. So yeah. This is just like some ideas to ponder about regarding Cloud Run. Okay, so I'm going down back to references, some additional references with regards to this Cloud Run tool. So a few references that might be interesting would be, there's a video from the Google Cloud Platform Singapore community group regarding the running of R Shiny server, and this R Shiny server it runs on WebSockets, and WebSockets is initially not exactly supported in most other like serverless platforms. Cloud Run now kind of supports it. So let's say if you have an app that requires WebSockets, now you can run it on Google Cloud Run. And you can do some other crazier stuff with it, where you can have this app that depends on these WebSockets. You can run it behind a load balancer, and then you can protect that load balancer with this new product called Identity Aware Proxy. So Identity Aware Proxy essentially is a product from Google where you need to be authenticated and authorized in order to be able to access a resource behind the load balancer. If you're interested in it, you can view that blog post and the corresponding YouTube video for it. Both resources are available for you. You can just check this link out. And then last set of references, additional link that you can look at. So the first link is essentially the documentation for Cloud Run. So that's definitely a good starting point on what you can do with it. The second one is kind of like ad hoc facts of Cloud Run. I think this fact page has been around since the start of the Cloud Run service, so you definitely will see like potential issues that had been around, but maybe now it's resolved. So might be a good read if you are like hitting into some kind of roadblock. Like maybe you try something and it doesn't exactly work. So if I'm not wrong, I don't think you can just run Nginx container as it is. Yeah, but correct me if I'm wrong there. Yeah, you can't like download engine container and upload it to Cloud Run and expect it to work as expected because of some like weird issue with regards to the file and how it accesses the ports. But yeah, I could be wrong there. So the third link is about Knative, and Knative essentially is the open source product of what this whole Cloud Run product is all about. So let's say if you are disagreeing to run this whole to run your workload on Google Cloud Run, and like, okay, I no matter what, I only support open source. You can have something similar to it by like deploying Knative onto your own cluster, but it's really quite heavy. What you need to do is run Kubernetes, then run like some sort of service mesh. The one that is officially available on Docs and easily available is this service mesh called Istio. And on top of Istio, you run another layer of abstraction called Knative. And Knative is the one that, it install additional components such that it will scale to zero if needed, all the revision URLs, managing the revision URLs, etc. So yeah, if you are interested from that aspect of things, you can check out the Knative project. There is a whole bunch of resources on like how to deploy it and how to manage it. Yeah, if I'm not wrong, there is this dude called Matt Atamel, METE ATAMEL. Yeah, I'm not sure if I spell his name correctly. He does cover a whole bunch of topics with regards to this, so might be worth a read to find his blogs and find out more about this specific open source product. So the other two is essentially alternative open source products with regards to this function as a service kind of methodology. But I mean, this is in the case where you're not going to use Cloud Run for it. And last one essentially is, let's say if you are interested to run Cloud Run, and then if you happen to be a R user, you can like check out this code base to see an example of how to deploy a R-based API service to Cloud Run. So yeah, that's kind of it. That's all I have to share.
All right. Thanks, Hairizuan, for the very interactive session. I guess I loved how your talk gave us a feel of the implementation of deploying a service onto Cloud Run via the GUI. Yeah, so now we're open for questions. So to our audience, feel free to drop us a comment or any questions that you have regarding the second session we had. Yeah, so right now I guess we have one asking if gRPC is supported on Cloud Run.
Yes, it's now supported. If you're familiar with gRPC, there's like okay. So gRPC, there's many ways to kind of dissect it. So if you check the documentation for it, there's like the unary kind of communication. So basically, it's client send a message to server and server send message to client immediately. There's streaming mode where client streams a bunch of messages to server, and then the other alternative is server send a stream of messages to client. So right now, if I'm not wrong, it supports all of these cases. In the past, it only supports unary, where client send message to the gRPC server, and then immediately respond back, because it doesn't support like opening the connection for a long time. But now it does, and I'm not exactly sure of how long that connection remains open. Let's say if you open a streaming from client to server and you want to send a whole bunch of messages, I'm not sure how long that connection will last. You might want to check the documentation for it. But yeah, this support comes alongside the WebSocket support. So Yeah. And also one thing that you need to take note in terms of this whole streaming is you'll be charged as long as the container remains live. So let's say if your server is like open and like accepting connect requests, right? Essentially, you are still being charged then. So you might want to take note of trying to reduce that if you are like trying to cut costs or something. Yeah.
All right. Thanks for answering that, Hairizuan, and I hope that we've answered that question. Yeah, so let me add Divya to the screen as well. Yeah, so once again, thanks to both of you for joining us today. Yeah, so to our audience, if you have any comments or any questions, we'll still be around for a bit. So feel free to drop in the chat. And also, if you have any topic requests for the upcoming sessions, feel free to share that with us as well. Yeah, so before we end, Divya, do you have anything to share with all our participants today? We can't hear you. Just...
Can you hear me?
Yes, we can hear you now.
Okay. Yeah, so what I was saying is like as the Vertex AI is the new launch tool, newly launched tool in Google Cloud, just try it out and, give your feedback, like how we can improve, because not all the features are currently available in Vertex AI, but your feedback definitely will help improve the product.
Thanks, Divya. And Hairizuan, do you have anything to share before we end our program today?
Okay, so just a few things. So do try out Cloud Run and see whether it works for your purposes. I think it does work best for if you are like doing it for like side projects or something. You can like deploy something and just leave it and forget it, because essentially it's mostly free, assuming that you don't use like special resources here and there. And another thing is so GDG Cloud Singapore does have a YouTube channel as well. So if you want, you can check out for additional content there. I think I do believe I left a link to one of the videos from that. So if you're interested, you can check out some of the other videos there as well. So it's like kind of a personal plug here. So yeah.
All right, thanks for sharing that. Yeah, so shout out to GDG Cloud community in Singapore as well. So do feel free to check out that if you want to know more. And yeah, once again, thanks to all of our audience who've joined us today. We're glad to have you all be part of this community. I hope you had a great time joining this event. And yeah, as mentioned, our speakers will be sharing the slides with you guys. And yeah, so feel free to use it for, to explore more stuff. And once again, thanks to all of you who showed your love and support. Yeah, I'll just drop it down there so that you guys can see. Yeah, so we have another question actually. Let me share that. Yeah, so the question here is, how can we deploy custom PyTorch model only for prediction on Vertex AI? Yeah, so they mentioned that the video tutorials are only available for TensorFlow models. So I guess, Divya, would you like to take the question?
Sure. So if you have a PyTorch models, it does supports PyTorch as well. So you can deploy your custom models as well. So Vertex AI have a custom model thing, so you can bring your own containers and you can deploy it on the Vertex AI platform. Do check out the documentations; it's available there. Maybe video tutorials will not be available at this point of time because product is quite new, but definitely in the cloud docs, right? Vertex AI docs, definitely it's there.
All right, thanks for answering that. I hope that we answered the question. Yeah, as for now, we're done for the day. So if any of you have more questions, we'll be sharing our speakers' social media platforms where you can interact with them. And if you have more questions, you can either reach out to any of our speakers or also, just ping us on, our platforms on Google Cloud KL. GDG Cloud KL. So that's it from us today. I hope you guys all had a great time. And yeah, that's all for today. Thank you for joining us again.
All right. Thank you,